Hi there, this lesson is about sketching graphs that are in factorised form. So factorised form means completely factorised form. So that's when the equation looks like this: x minus or plus a number, x plus or minus another number, and you notice that you have two brackets and no spares. So that's in contrast to what we call turning point form or partially factorised, where we had x minus a number all squared plus c. So these are versions of each other potentially, and it's just sometimes the way that the equations are presented to you. So we're going to have these ones here that are fully factorised, and there's some tricks for sketching them. Okay, so we're just going to write sketch here. There's the H. Okay, so here are the steps. So step one, what we're going to do is it's really a series of steps that you need to follow. So I'm going to follow my notes from last year. I'm going to say 4 steps. And I'm pretty sure there's a handout or something for this. There's certainly some Blackboard notes. I'm going to use the example that I have Blackboard notes for. So the example we're going to do is y equals x plus 1. X minus 3. So that's factorised into 2 brackets. Your first step is to find the y-intercept. So we're finding a point on the graph. So if I did a Cartesian plane here, the x's and the y's, the y-intercept is that where the graph cuts the x-axis or the y. Yes, it's the y. So it's the point where we go through the y-intercept. So that is also the point where x is equal to 0. 0. Okay, so let's make x equals 0. And so what we do here is we simply take these two x's and we change them to 0. So we're substituting in x equals 0. So the corresponding y value that we're now going to find is 0 plus 1 0 take 3, which is equal to 1 times negative 3. Okay, so that bracket's 1, that bracket's negative 3, multiplied together between the brackets, and that's negative 3. So we have now found one point on this graph that we can plot, and that's x is 0, y is negative 3. Let's go and plop it on this graph. That would be this point here. All right, so we've found the y-intercept of this graph. Step 2 is we're going to find the x-intercepts. Now that's the point where the y equals 0. That means that for our equation, x plus 1, x take 3 equals 0 for the y. Now just have a good look at this guy here, this fella. If you have this, you are basically going to do some solving for x. So you know the y is 0, you've got the y. Now you need to find the x. And we did a truckload of these, okay, didn't we? We did this term, either the first bracket is 0, so this is where the null hypothesis comes in, or the second factor, the second bracket comes to 0. Okay, so we're just solving that out for that equation. We're solving that equation. So x is either equal to negative 1 or x is equal to plus 3. So actually we have 2 points for that. We have negative 1 and 0 or 3 and 0. Okay, so we found those guys. I'm just going to come back to our graph here and put in negative 1 and positive 3. So I want to just mark those little points there. Okay, so we have 3 points. We can probably look at our graph and kind of sketch in a parabola there that's going to work. Just going to take those out. Backtrack. But we can do a little bit better than that. So one of the things that we're now going to do is step 3. We are going to find the turning point. So this graph here comes down here and it turns around somewhere in here and comes back up. So we're going to find that exact point, coordinate pair. So we're going to find the turning point, and it's a minimum in this case. It could be a maximum. That's where the graph turns around, and that's the bottom of our curve. So when we actually look at our graph, if I was to put in the axis of symmetry for this guy here, we're sitting in between -1 and 3. That's a space of 4 clicks, so it'll be here, to either side, okay? So this is the line here of x is equal to 1, and it is halfway between -1 and 3. Okay, now that's what you need to do. So your trick for finding the turning point is to find the midway x. So I'm just going to check my notes here, make sure I'm giving it to you in the right way. Yep. So you can just stare at it and go x equals 1. Or you can do it this way, where you go 3 minus -1 divide by 2. 3 minus -1 is actually a space of 4. That's the distance between 3 and -1. And if we halve that, that is 2. So 2 is the space between -1 and 3. This is a little bit long-winded. We actually already know that it's when x is 1 there. However, we can take that 2 and we can add it to one of the x-intercepts. So -1 plus 2 comes to 1. So that's where our x is of interest. Okay. Main thing now is to put x into the equation. So remember, our equation that we're graphing is y equals x plus 1, x minus 3. So we're going to swap that x's in the equation for 1 to find the corresponding y when x is 1. That bracket comes to 2, and we're multiplying it by this bracket, which 1 minus 3 is -2. So -4. Notice how I'm working down the page algebraically. Main thing there is we have a point now. The x value was 1, and the corresponding y value we calculated as 4. So if we come back to our graph here, on the yellow line, x is 1. Down here, x is 4. So we have now found where everything needs to go. We have 4 points, and we just sketch a nice smooth curved line between the 4 points that we have put on our axis there. So I'm just going to blow this up for you. So point 1 was the y-intercept here at 0, 3. Points 2 was 2 solutions for the x-intercept, and point 4, which is the third thing we did, was that turning point, that minimum. So I'm just going to grab somewhat different color. Let's go with green. And we're just going to take our pen, go past the last point there, turn around there. So there's the bottom of our parabola at the turning point. Not at this guy there, but here at the turning point. All right, so it looks a little messy. It'll look nicer on yours when you use real paper. So please make sure that you actually do that on a quad paper. It's okay to sketch like this, but also do some on quad paper. I'm going to label that turning point there as the minimum because it's at the bottom of our curve and it's equal to 1 and -4. I can see the solutions here is 0 and 3. When I say solutions, I'm x solutions. That's when we solve the equation. And -1, 0. What have I done here? So this solution here on the right is actually 3, 0. Okay, so I've labelled my 4 points. I haven't done the y-intercept yet, so that was at 0, -3. So just to make sure that I'm labelling this, I have labelled or sketched those 4 points. I have drawn a smooth line, and that's all I need to do, no step-out patterns. And the last thing I want to do is just label this guy here. So y equal to x plus 1, x take 3. That's his equation. That's how we trace the line. Notice these arms here go beyond the points, the highest points that I've got, which shows continuity, that graph goes below. Please don't stop on those 2 points there. Please draw it right through. Bit messy, but you can also see that this is on the whiteboard notes, that we would have done something similar in class. I'm going to do one more example because I think students like to see lots of these ones. And that next example I'll write up on the board for you. So I'm just going to sketch it up and then I'll do another video to show you how that one is done. I'll just grab my equation that we're working on. Next one is going to be the graph of x minus 1, x minus 9. Let's do it on the next graph, on the next video, okay? So you might want to write this down and grab the next video to have a look. Alrighty, thanks guys, bye.